All right. Welcome to our March 2025 Lunch and Learn, um, titled Salty Situations in Our Streams, featuring our wonderful guest, Harry Campbell from Chesapeake Bay Foundation. Thank you for being here, Harry. We appreciate you taking some time out of, life and work to come and chat with us for a bit. So, without further ado, I'll tell our audience a little more about Harry, and then we can get into the presentation. So, Harry Campbell is the Director of Science, Policy, and Advocacy in the Pennsylvania office of the Chesapeake Bay Foundation. He has nearly 30 years of experience in watershed assessment, restoration, and protection science, policy, and advocacy across academic, governmental, private, and nonprofit sectors. Prior to his current position, he spent nearly 8 years as the executive director of CBF's Pennsylvania office. A recognized innovator, he fostered efforts to successfully designate the eastern hellbender as Pennsylvania's state amphibian, create the Keystone Tree Fund, conceive the Keystone 10 Million Trees Partnership, and devise the first statewide, state-based conservation cost-share program in Pennsylvania, the Agriculture Conservation Assistance Program. He launched CBF's initiative to transform watershed planning in the state, an effort which was recently awarded over $3 million in implementation funds in the 2022 federal omnibus budget. Harry aims to continue advancing watershed protection and restoration efforts, focusing on innovative solutions to both long-standing and emerging challenges. He's a frequent guest lecturer, panelist, and interviewee in traditional and non-traditional media. Harry holds a bachelor's degree in environmental resource management and a master's degree in environmental pollution control from the Pennsylvania State University. And he grew up in northern Luzerne County, where he spent countless hours fishing and wandering through forest and fields. Currently, he resides in the Harrisburg area with his spouse, 2 teenagers, and an innumerable number of transient sentient beings.
Well, thank
Wow.
you, Natalie. I appreciate it.
Yeah.
And thanks, everybody, for taking the time out of your day to learn a little bit about an issue that's happening in a lot of our aquatic ecosystems across the United States, including right here in Pennsylvania. Formally, it's known as something called freshwater salinization syndrome. I will not subject you to that phrase too often. That's the scientific term for our streams becoming salty. Before I launch into all of that, just a little bit of more of a background on me, maybe more personalization. Natalie did a wonderful job talking about sort of my professional background and things that I've been able to do over the course of time. But as Natalie mentioned, I grew up in the northeast part of the state. That lake view was the view I looked at pretty much every morning as I walked down about a quarter of a mile from my house in the woods to this location where I started to really enjoy and observe like the power of the ecosystem in terms of just like where other fish were in this lake versus other areas, and the difference between the catfish and the chain pickerel, and where the smallmouth bass were versus the yellow perch, and the changes over the course of the time that would happen when we'd have a drought or heavy rain or really warm weather got me really interested in the power of observation, really observing the things that influence our environment ourselves, but just in terms of water quality. And I pursued that professionally through my undergraduate and graduate work. I currently work at CBF. A little bit about the Chesapeake Bay Foundation briefly. We're the largest nonprofit membership-based organization representing the effort to quote-unquote save the bay in the watershed. We were formed in 1967, established our Pennsylvania office in 1984 officially. But we do a lot of different things. We actually do a significant amount of engagement. We do restoration, a little bit on that, because we've actually changed this to the new recognition that we're never going to restore things back to the way they were before human habitation or colonialization. What we're really talking about looking forward into the future is resiliency, making sure to the best of our abilities that our watersheds are resilient to the constant pressures and changes that are occurring throughout them, whether it be from land use change or the changes in precipitation through a changing climate. We work on policy. That's where I spend a lot of my time, interjecting science into our policy work. And we do education and litigation as well. Our education programming actually spans the entire watershed, and we do significant amounts of what we call MIWI, meaningful watershed experiences, taking kids out uh, onto the water, particularly in that junior high, middle school through high school focal point, and having them experience the water and the watershed in a way that they oftentimes may not be able to because of their living conditions and other experiences. And the policy work we do is such as getting the Eastern Hellbender as a designated state amphibian recently, a couple of years ago, not so recently anymore, but it feels like just a few days ago, in my mind anyway, was one of a big thing that we had achieved. Bipartisan effort. Another bipartisan effort was the establishment of the Keystone Tree Fund. Anytime you renew your license or your registration online, there is an option to donate $3 to a myriad of causes. One of those is the Keystone Tree Restricted Account or Tree Fund that goes to help pay for tree plantings across the state of Pennsylvania, particularly in important areas like alongside streams and streets. And as Natalie mentioned earlier as well, we actually conceived of, wrote the legislation, garnered the champions, and worked in the legislature to pass the Agricultural Conservation Assistance Program to help support the over 50,000 family farms in the state of Pennsylvania in keeping soils on the and nutrients on the land instead of in the water. And that resiliency program, we do things where we were really looking at developing high resolution precision conservation plans that are looking at the types of practices that have high impact and have multiple ecosystem services while garnering the knowledge and experience and connection to people, that local knowledge that comes from the people and the partners that are on the ground each and every day within these watersheds. We've done a number of them, particularly in Pennsylvania, a number of restoration projects, primarily working with Pennsylvania's agricultural community, but we have worked in suburban and urban areas as well, and in helping to design and implement conservation practices. Just a little bit of a view of just the Pennsylvania portion as well, Lancaster County, parts of Center County, and also Mifflin and Huntington and Schuylkill even are part of that matrix. This is just an example of some of the projects that we work on. We really focus in on forested riparian buffers because of their ability to not only help keep pollutants from entering into a stream as they flow off the landscape, but also because of their ability to foster a biological environment that allows for the stream to cleanse itself. That's a whole other presentation, not going to get into that right now. But here is a stream in Lancaster County. And it was taken about 1999, prior to our restoration work there. And 12 years later, very same stream, very same location, fundamentally different after we planted a forested riparian buffer along that stream. You can actually even see the changes in the form and function, the riffle, run, pull, the makeup, the geomorphology of that stream has fundamentally changed just because of the planting of the trees. This is the natural condition of Pennsylvania's rivers and streams: forested riparian corridors, forested watersheds. This stream, which was once impaired, is now considered unimpaired and has naturally reproducing brook trout once again. So we work in communities and with partners and people all across the watershed to help design and implement practices, including trees across the state of Pennsylvania. And the establishment of the Keystone Tree Fund, or excuse me, the Keystone 10 Million Trees Partnership, we're actually wrapping that up at the end of this year. And we're at, and that was a weird little graph, I apologize for that, 8.2 million trees so far. And what we like to say is clean water grows on trees because they're so critical to our health in our rivers and our streams and our lakes as well. So we live on a blue planet. We all know this, right? We got a lot of water in this world. But did you realize that if we concentrated all that water, everything, all the oceans, the groundwater, all of the surface waters into a ball. That little ball of water is not something that we can readily take advantage of. In fact, the liquid fresh water is only about 2.5% of the Earth's total volume of water. Of that liquid fresh water that makes up the entire world, only about 1.2% of that is surface water. Of that surface water, only about 0.5% is made up of rivers and streams. Lakes represent the largest. In Great Lakes and other places, that's about 21% of the total water volume, freshwater volume in particular, in the world. To kind of put this in context, if you put all of the Earth's water into a 26-gallon size cistern, the usable freshwater supply that would be available to us right now is about a half a teaspoon. Now, that small volume of water does a lot for us. We rely on it for drinking water. The majority of Pennsylvanians get their drinking water from surface water sources. It sustains and helps feed our agricultural community, whether it be in terms of our crops, but also for the large amounts of animal-based agriculture, particularly in the south central parts of the state, but also throughout the parts of the Pennsylvania. And it provides the habitat, the ecosystems for the types of things that are significant economic drivers in a lot of our communities, like some of the world-class trout fishing streams that we have scattered throughout the state of Pennsylvania. Streams that are so renowned that people come from all over the world to fish those streams. These are significant drivers of our local as well as regional and statewide economy, supporting thousands of jobs and providing over $6 billion in economic activity each and every year. But as I mentioned, science is starting to see changes in our water quality of our rivers and streams. And in fact, over the last 50 years, we're seeing an increasing amount of salinization. This is representative of a 50-year study by the U.S. Geological Survey looking at 232 individual sampling sites. Over the course of those 50 years, they found 37% of the contiguous United States has an increased salinity in those drainage areas. And that's fundamentally changing the chemistry of those streams. But looking at it a little bit closer, one of the things that we do as scientists to measure salinity is something called specific conductance. And this is basically the way that how well an electrical charge travels a certain defined distance within the water column. And the more salts, different types of salts like magnesium chloride and sodium chloride and potassium chloride, these little things, these little dissolved salts, the more there are of them, the greater the amount of electrical conductivity. And they're seeing that in all these individual sites, an upward trend over the last 50 years, an upward trending of this specific conductance in these freshwater ecosystems. Trying to parse that out a little bit further, looking at the types of things that are part of that specific conductance, like the calcium and the sodium concentrations, as well as magnesium, they're seeing similar increases. The amounts of those elements are increasing in those streams that are being studied. Now, this can have a fairly profound impact on the aquatic ecosystems, our infrastructure that we rely upon, as well as our drinking water and our soils that we are so dependent upon in Pennsylvania and beyond. And it's important to note, though, that over the course of time, our rivers and streams are constantly changing, and they have natural amounts of these elements in them. Based on the river continuum concept, you can see how a river changes as you go from a small headwater stream down to these larger river kind of ecosystems where the fish start to change. They kind of change their form and function in terms of the macroinvertebrates. but also the concentrations that are naturally found in of salinity broadly or specific conductance also changes. But the research is showing that as that change is occurring, separating out that natural weathering and other things, we're seeing those macroinvertebrate scores, the things, the shredders, the predators, the other types of and the filterers, those mayflies, caddisflies, those types of really important bugs that live in the stream that are important for fish species, including brook trout. As the conductivity increases, the abundance and diversity of that macroinvertebrate population goes down. There's less and less bugs in that stream. And that has a profound impact on the fish population as well. I didn't include a slide here, but you would see a very similar trend that as conductivity has been increasing, the amount of macroinvertebrates, the abundance and diversity of them are going down, particularly on this site in the Schuylkill River Basin, or 157 sites. But it would also show the same pattern for fish as well, changing that form and function, losing populations of economically important fish in many cases, like the eastern brook trout. And we're seeing that trend in whether it be in the specific conductance, electrical conductivity, but also in the concentrations occurring in certain discrete areas. And the research is suggesting that we're finding them highly correlated in significant concentrations in places where there is urban or suburban lands. And it's changing because primarily we're building more and more places out. So if you think about what's happened over the last 50 years, is that there's been a heck of a lot of land use change throughout the United States, but in particular in Pennsylvania. As that land use change is occurring and we're taking farms, fields, and forests and turning them into subdivisions and strip malls, so do the parking lots, roads, and other things, impervious surfaces come along for that ride. To the degree to which now you're starting to see in certain situations, in this case in the Schuylkill River, where there are concentrations of sodium chloride, chloride in particular, that actually exceeds US EPA chronic toxicity standards for freshwater ecosystems like these rivers and streams. And in fact, that there can be even significant amounts of days in which that chronic toxicity criteria is actually exceeded. And that is then changing or causing the change and helping facilitate the change in the health and condition of our rivers and streams by changing the fundamental biologies of them. It's also unfortunately affecting the streams indirectly, but our soils and the vegetation. As we're starting to see increases in amounts of salts, there's a corresponding increase in the amount of salty soils. These soils are then changing what can grow. And the microbiological and fungal populations within those areas is fundamentally changing as well. And that has a direct impact or an indirect impact on the health condition of the rivers and streams. But we're seeing more and more cases of salt scorch on even people's lawns, like in this case, where there's been an excessive amount of salt applied, de-icing salt in particular. Another example is this is actually from Georgia, but where there was liquid brine applied. And the spray that was put onto the sidewalk has actually scorched these arborvitae plants. But we're also seeing impacts on human health as well. This is all well and good, a couple burnt vegetation, some changes in the microbiological and macroinvertebrate populations. Who cares, of streams? Well, you may recall just a few years ago that Flint had a big issue with the lead contamination of their drinking water system. The driver for that change was an excessive amount of chlorides that found their way into the system that then facilitate, through a chemical reaction, the leaching of lead from older pipes. And so as these rivers and streams are changing in their form and function, if you do not have a treatment system that is able to effectively remove, in this case, the chlorides that might be coming from these changes in salinity that are happening in our rivers and streams, you will start to see excessive concentrations to the point of human health concern of lead. Now, Pennsylvania has a lot of watersheds and a lot of surface water intakes that are naturally at risk. This actually shows on a scale of 10% increases the level of propensity that the natural condition of the rivers and streams could cause the leaching of lead in older systems. And so we see large swaths of parts of Pennsylvania, particularly in the rural northern and northwest parts of the state, with the high potential for this to occur in our systems. Made further worsening is that as specific conductivity continues to increase, so does the survival of certain types of bacteria that we do not want to necessarily ingest or have come into a cut on our skin. Thus, therefore, increasing the potential rate of infectious diseases that make our way into our bodies. As salinity or as specific conductivity increase, so does unfortunately the survival rate of something like E. coli, which obviously can give us acute gastroenteritis. These issues have a direct impact, whether it be in terms of the neurotoxicities of lead potentially, or even these bacterial contaminants and their survivorship in our drinking water sources, but also in our freshwater streams where we may have some partial or full body contact as well. And then the other impact to the increasing amount of salinity across our streams is also the degradation of our infrastructure. Now, you don't see this as much as you used to, like when I was growing up, really rusted out vehicles. That's because they've actually changed the way that they manufacture our vehicles, a lot more plastic. But nonetheless, as that change occurs, the metals on our roads, on our vehicles, is actually causing more rust to form. But maybe more significantly and concerningly, it also is a significant driver for the degradation of our infrastructure, like our bridges. In fact, it's estimated that the damage from salting highways alone right now costs the United States $5 billion a year. About $100 worth of road salt, that's about, in the current marketplace, about 2,000 pounds, so a ton, can result in about $3,000 of infrastructure damage for our roads, highways, and bridges. So why is everything becoming so salty? Why are our rivers and streams in at least almost 40% of the United States getting more salty? Well, there's a couple of reasons why. As you can imagine, our watersheds, and the hydrologic cycle, the water cycle, it's a constantly flowing system. It's gonna flow, it's gonna move, it's gonna cycle, whether we're here or not. Under natural conditions, the flow of erosion and the flow of water is occurring over the course of generations, multi-generations, thousands of years. As we change the form and function of our rivers and streams and the landscapes, we're starting to accelerate certain things within that context, or whether or not there's an increasing amount of precipitation due to a warming climate and other changes. We are altering that hydrologic cycle. So the salinization can occur through three major routes: natural weathering, anthropogenic inputs, human, and biological alkalization. We're going to focus real quickly on the anthropogenic or human inputs, and one in particular that has changed substantially over the last several years, and that is road salts. Road salts are ubiquitous. Any place we have roads, we're salting them in the river in the winter. So there's a large amount of that happening in our suburban and urban areas. This is just from my neighborhood, right here outside of Harrisburg. And you can see this is just a couple of months ago, piles of road salt that were left because of the municipal salting of the roads during a winter storm that was coming. or even the amount that is left over after that storm event on people's walkways and sidewalks. There are just large amounts of salt being applied to our impervious surfaces in the form of rock salt in the solids, but also in the form of liquid brine, liquid salts. Like imagine spraying salt water from the ocean onto our roads. That is happening at a number of places as well, particularly on state roads. Pennsylvania is part of what's known as the Salt Belt in the United States. Now that means what that means is that there's a lot of salt that's being applied. We are in an area where tons of salt are applied each and every year. And that's because they like to do that because it is actually helping to melt and de-ice the snow and the melt from our road systems. Over the course of the last 60, 70, 80 years in the United States, we have had significant increases in the amount of salt that has been being applied to our systems across the United States. And in fact, about 25 metric tons or 48.5 billion pounds of salt have been applied to roadways in the United States each and every year since about 2000. That's about 12 times increase from 1960. It's about a 5-time increase from about 1990. Our amount of road salt application in the United States is exponentially growing. I just forgot I had that there, but basically 4.8 billion pounds of road salt each and every year. In Pennsylvania, since 2000, PennDOT has reported, just PennDOT, not municipal roads, just PennDOT, applying 1.2 billion pounds of salt to state roads since 2000. So each and every year, about 1.2 billion pounds of road salt are applied to state roads. We don't have a good estimate as to the total from municipal and other areas like on private, but that's still a heck of a lot of road salt application across Pennsylvania. So one of the things that recently occurred is that there, because of this growing concern, a national consortium of entities across the United States got together to actually do a educational assessment, an educational outreach about the impacts of salt on our rivers and streams and freshwater ecosystems. It was called Winter Salt Week 2025. You may have heard of it, you may have not. We joined with a number of other organizations, led by the Stroudwater Research Center in Pennsylvania in the Mid-Atlantic region, to not only help amplify the message about the impacts of road salt in our aquatic ecosystems, but also we went out and did a sampling day to take a snapshot of the health and conditions of select rivers and streams throughout the state of Pennsylvania, or at least where we could within the footprint of the participating organizations. Here's the results. This is all occurring on a one day. There were 367 sites that were sampled. About 71% exceeded at least one salt-related concentration toxicity threshold. There's different thresholds for different types of ecosystem and different types of things living in those streams, but nonetheless, the majority, 70%-ish, actually exceeded at least one of those. The highest 100 chloride values were found in the smallest of streams. So those small streams that you can kind of jump over, they're called first order streams, sometimes second order streams, but they were found in those small streams and correlated with urban and suburban streams. So reinforcing that urban and suburbanization influence and association on the increasing amounts of chlorides in our rivers and streams in Pennsylvania. Focusing in a little bit on the Harrisburg region, these are the sites that CBF, my organization, was able to capture. And we were a little bit strategic on where we chose to do this based on some projects and work that we have related throughout the Harrisburg region, including of Lancaster County. But as you can see with these results, you don't need to know about like really look and dive into the numbers, but you just look at that graphic and the change in the color schemes. There were certain sites that no matter what standard you use, that first standard, PAPWS, excuse me, is our standard that we have as a state of Pennsylvania for potable water supply protection. And that last site in the unnamed tributary to Clingersville Run, it exceeded every standard, including that highest standard. Others were a little less, maybe shall we say, salt laden. With the Yellow Breeches Creek, the second site being the best out of all of them, but still not all that great for the SBI, which is the salt excuse me, salt belt index, and it's sort of that threshold between salt being influencing rivers and streams. The natural background of freshwater ecosystems in the Pennsylvania and the Mid-Atlantic region is a concentration, chloride concentration of about 5 to 10, maybe 20 milligrams per liter. And that's the top level threshold. Looking out your way a little bit, there's not much in terms of, unfortunately, participation. Might be an interesting thing for you to consider doing. There were a total number of 18 sites that were sampled outside in the Pittsburgh region, a little southwest of Pittsburgh in particular. And your mean chloride standard was just under 400. That's pretty high, to be honest with you. That's really high, actually. And the next part would be to look and see whether or not it's associated with any activity, whether urban, suburban, or whether that actually might be some sort of anomaly. But increasing the amount of sampling sites would be important to getting a greater understanding of what's happening, even in a snapshot grab sample kind of way. Nonetheless, here we are. We demonstrated that over the course of time, across the United States, there's increasing salinization. We're seeing it in Pennsylvania. What in the world can we do about it? Because we don't influence PennDOT. We don't also simultaneously want to have roads that are icy and unsafe and have more accidents. So what are the things that we can do? Well, there's a number of things that at least we as individuals can do in our own backyards, in our own front yards, on our own property, but also in our communities to a degree. And really, it's about the 5 R's. It's like the really understanding, like, okay, let's shovel first. Let's do that to the maximum degree we can. Let's use the right amount of salt. So it's not a more is better type of an approach. We can be right and more precision about where we put our road salts instead of broadcasting it all over the place, including onto our lawns or onto the streets and other places where it can run off and get into our ecosystems. We can be more precise in the locations that we are applying that salt. So not just the amount, but also the place that we are putting them. And then, of course, sometimes we can use mechanical means to actually protect ourselves by using different boots or putting on straps that have spikes and things of that nature. And a critical, important part of all of this also is raising awareness and really helping to bring this issue to the attention of municipalities, people, and even PennDOT, who is exploring alternatives to the type of uses, alternatives to road salt. And there are some that we have at our disposal right now that can be alternatives to the traditional rock salt that you would buy at the hardware store, at the grocery store. Unfortunately, none of them are either particularly that effective or efficient or less toxic. The bottom line is that, to be quite honest with you, there's no perfect alternative yet. And really what it is about applying those 5 R's. If there was anything that probably has the least amount of potential impact on the aquatic ecosystem in particular, while maintaining a level of effectiveness, it's CMA, that calcium magnesium acetate. It's not perfect, but because of its cost, it's a lot higher than a lot of other things. But at the same time, It is effective, but it does carry some heavy toxicity aquatically. But in any of that was one, however, that doesn't actually have concerns for like your pets. So it's less toxic to dogs that may get it in their paws and in things of that nature in their pads. So there's options out there. None of them are perfect. Each come with drawbacks, but nonetheless, there are other things that we can do to try to help alleviate the impact. And there's a growing number of communities and states that are looking at alternatives. There's things like beet juice and pickle brine that has been sprayed on, but those are all kind of chemical interventions. Some things that are happening actually parts of the United States are more precision-based, satellite-based information about on the temperature of roads, the iciness formation on those roads, that are then sending that information through satellites to management agencies so that they can actually then in the trucks themselves not only say where we need to go, but use a more precision based amount as to where to apply it as well, because they'll have advanced information about the actual condition of that road system instead of presuming, well, we just got to put more everywhere so as to cover our bases. The other thing is part of the five R's, and that it really wanted to emphasize is communication as well. And this goes well beyond just this issue, but it's critically important that we are communicating to people beyond ourselves and speaking in ways in which they can understand and actually empower them to help make decisions. So I encourage you to explore ways that you can continue to do the good work that you're doing, but also reach out to those communities that may not be necessarily part of your normal communication networks, and hopefully then not only get their understanding but appreciation and valuing for our environment broadly. Now there's always a but, and one but is that in addition to traditional road salts, over the last 10, 15 years, with the onset of unconventional gas well drilling in the state of Pennsylvania, in addition to the conventional drilling that's been going on for centuries now, we're seeing municipalities and counties utilizing that brine, parts of that flowback water on their roads. It's naturally super salty. So there's challenges with its treatment, there's challenges with its disposal. So some folks are thinking, well, let's go out and put it on the roads because it'll help remove or ameliorate those snow and ice conditions. It's banned officially in the state of Pennsylvania from unconventional shale gas drilling operations, but it is not prohibited through its application of conventional non-hydrologic fracking type gas and oil drilling. And so it still continues to exist in parts of the Pennsylvania, including in these areas that I'm showing here, that's from Frac Tracker. Now, if you remember that study that I talked about in Winter Salt Week, I'll get to that in a second. You'll see that that's an area that we have very limited information. But this type of drilling and its wastewater is of growing concern because of its not only aquatic toxicological impact, but also because of its human health concerns, particularly those that actually carry with them radioactive materials. Now that's primarily in the unconventional realm with hydrologic fracking, but nonetheless, a lot of the concern also exists with conventional oil well as well. And that's not only being used for ice, road, and snow removal, but also for for dust suppression on a lot of our dirt and gravel roads, which are a significant part of our rural road network in Pennsylvania. So you remember, this is where we did those studies, that snapshot back in January across the state of Pennsylvania. The area that has the activity occurring with the spreading of the flowback water from well drilling in Pennsylvania is an area where we had no samples, unfortunately. So it's an area we just don't know right now whether or not there is any sort of direct correlation to any significant degree, of that activity changing the salinity of the streams and to what degree. There's other science out there on this issue, and certainly more of those very discrete watershed studies. But looking at it from a very broad perspective, the information is currently lacking. And then, of course, the other big but is that over the course of time, we're seeing changes in our precipitation rates. And that increased precipitation may mean that in the winter, we're getting more snow or more slush, but it also means we're getting more precipitation and heavier precipitation during the non-winter months. And that is actually pulsing the sediments and the things that are attached to it, like salt, into our rivers and streams. It's going to continually be a problem, particularly in the eastern parts of the state, as it's projected to increase substantially over the next 100 years. This is a projection of that change in precipitation and divided by the number of extreme precipitation events to give you a sense of like that impact. And this would be what would occur at was projected to be the normal on an annual basis around 2100. And as our world continues to alter in terms of the changing planet and the climate associated with it, that increased runoff is not only going to carry traditional nutrients and sediments and other pollutants of concern to our rivers and streams, but also hydrologically overload our streams, causing erosion and of the bed and bank, the loss of habitat, but also the influx of things like salts that are alongside those rivers and streams or on those road networks into those aquatic ecosystems. So we could do this all alone and look like this guy. It would be tired, muddy, and probably not very successful at the end of the day. But if we work together, we'll still be tired, we'll probably still be muddy, but I think we'll be far more successful. And part of that is reaching out to those communities and communicating about the value of our aquatic ecosystems, whether it be the Chesapeake Bay or the Susquehanna River or the Monongahela or Allegheny River, or all of these watersheds, and their importance to our culture, our heritage, our economy, and our future for the quality of life and well-being of all Pennsylvanians. So if you're interested, feel free to jump on our website and join us if you so like. We have, like I said, we're a membership organization. We do a lot of advocacy work, science and policy. Or you can reach out to me directly if you have any further questions, comments, or concerns about this issue or any other issue regarding water quality in the state of Pennsylvania. So thank you.
Yeah, thank you so much, Harry. That was wonderful and extremely informative for me, especially. So I just want to open up to our audience a little bit. If you have any questions for Harry that he can answer, feel free to stick them in the chat and we will pull them up and ask away. In the meantime, I do have one question that I thought of during the presentation. So, especially when you brought up road spreading, and more related to the unconventional gas road spreading. You know, we deal with that a lot in our policy work here at Protect PT. So I'm curious to know like the effects of that radioactive, toxic, salty waste, specifically on watersheds. How that's affecting the ecosystems and down the line, how it's affecting communities.
Yeah, that's a great question. And I think it's one in which officially the science is still maturing.
Mm-hmm.
But the simple fact of the matter is that when you introduce these contaminants like the strontiums or uraniums, these types of naturally occurring but radioactive materials, when you introduce them into like an aquatic ecosystem or onto our roads, you're simultaneously increasing the potential for human exposure.
Mm-hmm.
So those things exist, they're naturally hanging around, but they're deep in places that we're obviously not going to be present. So while the science of like the actual measurable, quantifiable associations and correlations is being continually explored, the simple fact of the matter is that we're increasing the risk of potential exposure. And that exposure to contaminants like that is oftentimes going to impact younger populations more so than adults and older adults in particular. One, because their body size is smaller. So just think about a 1 gram of any type of pollutant or any type of medicine is going to have a greater impact on a small bodied person than a large bodied person. And that includes radiation exposure as well. And then two, they have a longer life expectancy. And a lot of these contaminants don't show their toxicity, whether it be mutagenic, carcinogenic, tetragenic, or otherwise, for years, if not decades later. So the exposure and the length on which you have your body has to deal with that exposure is also going to be affected or otherwise influence what we see as the human health impacts associated with it. So I can't say with absolute definitiveness that yes, we've proven X, Y, and Z. There's growing amounts of concern that when this is looked at, they're finding it in places it shouldn't be, and those places that it shouldn't be are places that people are or wildlife is, and it can actually bioaccumulate in some cases into that wildlife. And if you actually consume that vegetation or that um, those animals, then you are consuming that as well. So there's a lot of concern, but unfortunately, the science is still, as far as the definitive of it all, is still maturing.
Right, right. And that makes a lot of sense, that, the jury's still out on that one. Because it is something that is, not talked about so much by, the oil and gas industries. That it's sold as a salty solution. It's not really uh, said about the risks
Mhm,
that are involved with it. So, I mean, I think that makes a lot
mhm.
of sense. And I would be really interested to see, some of the data that comes out of that sampling, in northwestern parts of Pennsylvania, especially. I mean, I think there's a lot to be said for that.
Yeah, yeah. I think the what's critically important is that we need to be looking. If we don't look, we won't know.
Absolutely.
And that's what's so critical to the type of science that is just gathering information that sometimes may not even necessarily know why it's gathering what it's gathering for, but it's just baseline information that is oftentimes used as historically, like people start to see changes over the course of time of a certain parameter, and they will start to wonder why, and then they do statistical analysis, and then they do further studies. But then we find that's when the aha moment comes,
Hmm.
because you are collecting this body of data that may or may not tell you something, but it actually sometimes does. And the unfortunate reality is that type of science has been harder and harder to come by for a myriad of reasons. And one of them being that people don't necessarily, as a collective body, value it as they once did. And so legislatures don't value it as they once did. And so if they don't value it as they once did or want to hear about what is happening on the ground, they'll tend to start to underfund it and or eliminate it and pretend that it doesn't exist. Simultaneously, our ability to really, really identify contaminants that are emerging from going from like a parts per million milligrams per liter down to parts per billion trillion has increased because of our science and engineering. Well, now we're finding things that 15 years ago we couldn't even analyze. And so the more we look, it's like the burden of knowledge. The more you look, the more you find of all kinds of things that are problematic, including microplastics and other things.
Hmm.
Um, so yeah, this kind of basic research, but I think like things like the Salt Week and others are a nice bellwether to see if is there a problem and where, and then you can do further analysis of like why, and is
Yeah,
it a
yeah.
chronic issue or yeah, yep. So
And I think like it really goes back to the sentiment that you left us with in the presentation, that communication really is the basis and foundation of all science. I mean, especially, in this type of scenario where we are talking about, the water that we drink, the water that our kids play in, the water that, your dog might swim in, there's reasons why we need to test and look into these things so that we're able to appreciate something that we've had all of our existence, and we want to be able to continue to do that.
Yep. Yeah, exactly. And I think the more we can diversify that message and the messengers, I think the better we'll be. One of the most frustrating things for me, and this is a very blanket statement, but nonetheless, I deal with a lot of scientists, academics,
Hmm.
and engineers and others, and they, they actually, it's like they are very challenged to sometimes speak outside of their comfort zones. And to me, like I'm constantly trying to encourage that, whether it be engaging with legislators or talking to community groups and others. I think it's changing over the course of time a little bit, but it's still very difficult at times to have those types of learned individuals that have a lot of information and knowledge being able to talk about it in ways that in which it is meaningful and impactful and actionable at a local level, whether it be a municipal level with the decision making or at some other scale.
Yeah, absolutely. And I think like that has been such a large approach of Protect PT work and a lot of
Hmm.
other smaller environmental nonprofits work is that you have to hit environmental issues from multiple angles. You can't just talk about the science. You can't just talk about the legislation. You can't
Yep.
just organize people. You have to have, these are all parts of a whole to make
Hmm.
your mission and your goal successful. So
Yep.
I completely hear you.
Yeah. Yeah. That's very true. Very, very true. I'll just leave you with this. One thing that is somewhat unique, unfortunately, with the United States versus, say, like the European Union is, I don't know if anyone has heard the term precautionary principle. And that's we do this with our contaminants. We do this with a lot of our chemicals that are in our manufacturing, as well as in our food industry. In the United States, you have to prove that it's deleterious, it's harmful, to get it taken off the market. In
Hmm.
other places where the precautionary principle is applied, you have to prove that it's safe before can be on the market. And I think if we could have a cultural change that expected that, we may ultimately have a change in our rules and regulations that then embodies that perspective. So that, and for that to occur, we need to have people demanding it, just like they did in the early 1970s with the formation of the Clean Water Act and Clean Air Act and all of these sentinel environmental laws that we passed back then.
Absolutely. Absolutely. Well, I want to thank you again for being here with us today and thank you for all of your insight. Once again, if like anyone wants to, reach out with any questions you might have after this presentation, feel free to reach out to myself or to Harry, whichever you may so please. And we'll be sure to, get back to you. And then I will leave us off on the note that we will be doing another lunch and learn next month on the last Tuesday of April, which I believe is the 29th. So make sure you stick around and come join us for that one. The topic is still to be determined. We've been having a very busy month of Protect PTs, so we are working on that. But once we have more details, we will get that out to everyone. And yeah, we look forward to having you all back watching us so we can, educate a little more. It's our favorite thing to do at Protect PT. So we're happy that all of you have viewed today. And once again, thank you to Harry Campbell. This was a lot of fun.
Thank you. It was great. I love it. I appreciate it. Look forward.
All right. Goodbye, everyone. See you next month.
Be well.